In the following video, we're going to practice some of the problems on our assignment to build our understanding of rational exponents. We're going to focus on the odd problems. So in the first set, on 1 through 7, the odds, I'm asked to write each expression in radical form, or write each radical in exponential form. So if I look at number 1, I am given 3 to the 1/6. So I'm given it in exponential form, so I need to write it in radical form. To write it in radical form, remember the first thing you do is look at your denominator. It's 6. Now what that tells me is I'm dealing with the 6th root of my value of my base, which is 3. Now since the exponent is 1, I don't need to worry about it, and so my final answer is the 6th root of 3 for converting. If I look at example 3, the square root of 51. So now I'm going backwards. Since this is the square root, we need to remember what that means in exponential form. That means your denominator is 2. So really, this is 51 to the 1/2 power. Let's look at example 5. We have 12 to the 2/3 power. Again, first thing I always do is look at what my denominator is, and it's 3, because that tells me my root. I'm going to be dealing with the cube root of 12. Now I'm going to write down both forms that you can have for your answer. It doesn't matter which one. You can have the cube root of 12 and leave the 2 on the inside. So the cube root of 12 squared. Or since it's a number, I prefer to write it as you have the cube root of 12 and then put the squared on the outside of parentheses. If you have c cubed being raised to the 3/5 power, well, what we have to do here first is we can't work with it as is. We're going to apply our power rule. We're going to take the number on the outside and the exponent, multiply it. So 3/5 times 3 is 9/5. So really I have c to the 9/5 power. So that is exponential form. I need to convert to radical form. So 5 is my denominator, which means I'm dealing with the 5th root. And so since it's a variable, I just like to leave it as is, 5th root of c to the 9th. When it's a number, I prefer to put my exponent on the outside because then I can find the value easier. If I have a variable, I prefer to have the exponent on the inside because then it's easier to simplify when necessary. If you don't prefer it that way, then what you would do is you would have 5th root of c and then that being raised to the 9th power, which is harder to simplify with variables. This is the easier one for variables, and this is the easier one for numbers. So now let's apply these, and we'll practice evaluating each one. In number 9, I'm asked, take 32 to the 1/5 power. Well, that really means if I were to think of it like a radical, you're taking the 5th root of 32. Now for me, you should know the powers of 2 at least to the 5th power by heart. I mean, it's not a large base, it's 2. I mean, 2 to the 1st is 2. 2 squared is 4, that's easy. I mean, then cube it. 2 cubed is 8. Remember, 4th power, the quickest way to do it is to square the square. So 2 squared is 4, 4 squared is 16. And so for the 5th power, you just take the 4th power and double it, which gives you 32. And so you should know, for me, what the first 5 powers of 2 are by heart or be able to find them very quickly. And so you should know, without the use of a calculator, that 32 to the 1/5 power, or the 5th root of 32, is the value 2. Same thing, 27 to the 1/3 power is the cube root of 27. For my class, you should know 3 to the 1st power, 3 squared, 3 cubed, and 3 to the 4th. At least the first 4 powers of 3. If you know the first 5 powers of 3, that's awesome, that's better. 3 to the 1st is 3, 3 squared is 9, 3 cubed is 27. And again, to do the fourth power, square the square. So 3 squared is 9. 9 squared is 81. So I know the cube root of 27 is really 3 without a calculator. That is your expectation without a calculator. How can we use our calculator, though, to help us out? Well, we are raising a base, we'll do 32, to a fraction power. So 32 caret. And so now what I'm going to do is if you have the old operating system, since you're typing in a fraction, you would hit the parentheses button. For me, it puts, since I have the new operating system, it puts the exponent already there. It lifts it up to be our superscript. And so I'm just going to type in 1 divided by 5. I don't have to worry about the parentheses because it's already there. But if you have the old operating system, you would have 32, then your caret, you hit parentheses, and then 1 divided by 5, and you would close the parentheses. I would just hit the right arrow to come down. 32 to the 1/5 is 2. I can repeat the process of 27, hit the caret, and type in 1 divided by 3. Again, the old operating system, you have to be careful. You have to make sure you put a parentheses after the caret. And then 27 to the 1/3 is 3. And so I can check these with my calculator to verify it. However, like I said, for 9/11, those powers should be known by heart. 16 to the 3/2. So if we want to do this, we need to break this apart. And the way you break it apart is you break apart the denominator. You really have 16 and you have 1/2. You know, half is your denominator, you have 1/2 as your power, and then put your 3 on the outside. Remember, raising the half power is the same as square root. So the square root of 16 is 4. And so I'm really taking 4 cubed, which is 64. So when you're trying to deal with a value in the numerator that's not 1, just split it apart. Take the denominator, which is half. So you have 1/2 as your power, and then put the 3 on the outside. I have 27 to the 1/3 times 27 to the 5/3. Well, I have the same base. So that means I can add my exponents. You know, 1/3 plus 5/3 is 6/3, which is 2. So really, I have 27 squared, and 27 squared is 729. The other way you could do this problem is deal with the 27 to the 1/3 power is 3 and then break this apart and go from there. I prefer to combine them together into 1 and hopefully be able to simplify my exponent to make it easier. So in number 17, it's the same idea. I have the same base. And so it's really my product rule. If I have the same base, I can add the exponents. So 12/5 plus 3/5 is really 15/5. So I have C, 15 divided by 5 is really 3. So I have C cubed. 19, I have my power rule. I have an exponent on the outside, so I bring it in by multiplying to the exponent on the inside. So 3 times 1/2 is 3/2. So I have Q to the 3/2 power. 21 is another example of our product rule. X to the 6/11 power times X to the 4/11 power. You have the same base of X. So you just add your exponents. 6/11 plus 4/11 is really 10/11. And so my final answer is X to the 10/11 power. And last we have from 23, Y to the 1/2 power over Y to the 1/4. This is our quotient rule, which says when you're dividing like bases, you can subtract your exponents, and 1/2 minus 1/4 is 1/4. And so Y to the 1/4 is my power. The last one that is the most complicated one is the 12th root of 64. To do the 12th root of 64, what I'm going to do is I'm going to convert to my rational exponent form. That'd be 64 to the 1/12 power. Now for our homework, this is fine. For the value, not good enough, and not good enough to go to the calculator. We're going to have some fun and figure out what does it mean to have the 1/12 power. Well, 1/12, I don't know. But what's nice about 64 is I know 64 is a perfect square. It has a square root, which means it has a 1/2 power. So what 1/2 times what is 1/12, and that would be 1/6. And so what I do is I split this apart. I split it apart. I'm going to do 64 to the 1/6 power, and then raise that to the 1/2 power. And the reason why 64 to the 1/6 power is 2. And so my final answer is 2 to the 1/2 power, which is also the square root of 2. Hardest problem that you can have with translating back and forth between rational exponents and radical form. However, it is nice to be able to see why rational exponents are helpful compared to radical form. For your homework, please just leave it as translating. You don't need to go further, but I wanted to show you how we can break it apart and use rational exponents to find the exact value.